Hey guys, and welcome to the show. Today we're going to talk about credential theft. Hey guys, and as I said just a few seconds ago, we're going to talk today about credential theft. We're going to do a whole series on cybersecurity. I think it's a very important topic. We've had lots of high-profile security issues in the news, and so we're on top of that, and we want to make sure that you guys are on top of it. So I have with me today Mark Simos with Microsoft. He's a cyber architect. Mark, say hi.
Hey, how's it going?
Pretty good. So you're going to talk to us today a little bit about credential theft, correct?
Correct. And credential theft, most people know it as pass the hash, but yeah, that's the class of attacks we're going to talk about.
Okay. Awesome. Can you give us a little background?
Sure. So my name is Mark Simos. I'm an architect on the cybersecurity team. We deal with a lot of different cybersecurity issues, and one of the biggest ones we face is credential theft. So attackers have effectively learned how to steal logon credentials in a very quick and efficient way, and so they're starting to use that to gain control of customer and organization networks. So we help them quite a bit with protecting those environments.
Yeah, and they don't need to steal an admin credential at first, right? They just need access.
Correct. They usually like to get to the point where they're able to steal the admin credentials, but they can really steal any type of credential using these techniques.
Yeah. So they can steal a credential, get into a box, figure out some higher level privileged credentials, steal that, and work their way up.
Correct. Yeah, we call it privilege escalation, and that's exactly what they do.
Yeah, we just had an issue like that at another customer. I can't say who, of course, because we are very discreet about some of that stuff. But certainly something that people have heard about in the news and read about in the news.
Yes.
So you've got a slide deck for us. Is that correct?
Yeah, I was going to take just a few minutes here to walk through a presentation that we normally give to our customers on a one-on-one basis. And just kind of give a sense of the visual of exactly how these attacks unfold.
Yeah, I think that would be great because I think that customers need to understand, how they're vulnerable, how they can prevent it, and, if something like that occurs, what they can do to kind of mitigate it.
Yeah, definitely. I mean, this is I really compare it to the days of the Melissa, the I Love You, the SQL Slammer worm. I mean, the impact that these credential thefts attacks are having on our customers is that significant. Unfortunately, these are silent attacks, so you don't see something in your inbox, you don't see your SQL server go down. So we have this situation where the impact is there, but the visibility isn't. So we're really happy to be able to talk to you guys today on this call.
Yeah, you mentioned the I Love You issue, and all I can remember is my mom being so excited that all of her kids loved her so much. So it was pretty funny. I had to explain to her, no, that's not what that means. But yes, we do. Without further ado, let's dive into it.
Sounds great. Yeah, so when we talk about these cybersecurity attacks, one of the things that we like to talk about first is really kind of just where Microsoft comes from in the cybersecurity realm. And one of the interesting things about Microsoft that most people don't realize is we have what we call billions of sensors out there, because for the most part, everything that's electronic is instrumented these days and has some sort of feedback mechanism. And so Microsoft is very unique in the industry that we have all these different businesses that we're in and all these different capabilities we provide around a search engine, corporate email, as well as the sort of free consumer email through the Outlook.com. We are an anti-malware company. We've got a digital crimes unit that essentially helps law enforcement take down these various botnets that do exploitation. And so we end up with a lot of data from all of these different things just by providing the services. And so we end up with a pretty good perspective of what kind of malicious web pages are out there, what kind of emails. If there's a piece of malware out there, is it unique to a particular organization because they're being specifically targeted with it? Or is it more common, or is it only been seen within a particular geography or industry? So we end up with a lot of that sort of intelligence. And so that was kind of that broad view that Microsoft has in cybersecurity. And one of the things that a lot of customers don't understand is that their Premier contract effectively gives them access to a flyaway teams as well as phone support on incident response. If you're under attack, you can call Microsoft, through the normal Premier channels, and open up an incident and have that investigated either on premises or over the phone. And so we end up with a lot of data and a lot of understanding of what's going on in the cybersecurity space through that. So that's kind of where we get our information from. And then additionally, we also have a number of enterprise services through Premier and our consulting practice, where we really try to bring the best of this to our customers, including our normal sort of infrastructure and support and building and development skills as well. So we really try to bring all that together, and so that's kind of how we approach the cybersecurity piece. And a lot of this is actually published in various different ways. So we have a great paper. It's a little bit older, but it's an absolutely wonderful paper that describes how these attackers work and the fact that they're not tied, like in those days of the SQL Slammer, it was about a particular vulnerability and how many places you could get with that vulnerability was kind of the question. And what we're seeing now is a little bit more of a pivot to, I want to get credit card data, or I want to get designs for a new product that hasn't been released. And we're seeing the adversaries focus around that. And the techniques themselves can come and go, and they'll gladly use a different tool or technique if it helps them get to their objective. So we have a great paper that describes that shift in mindset. The other piece is a lot of those intelligence sources that we mentioned are actually available through what we call our SIR, our Security Intelligence Report. And so that's a great report that we release about every 6 months or so that has the latest and greatest on what we're seeing. And we also have provided in recent reports kind of what Microsoft sees on our network for benchmarking purposes. So you can say, hey, we have this much malware in our environment and this many types. Well, you can look up Microsoft status and say, okay, where are we versus what Microsoft is seeing to provide that glimpse. And it is difficult to find that anywhere else. And the credential theft piece, we actually have a whole dedicated portal set up, Microsoft.com/PTH. And that's really where we post a lot of resources. There's some Q&A videos, there's some white papers, there's some links to a number of other resources around the web. And this is really where we put all of our best recommendations and guidance around how to deal with this problem, because it is a very challenging problem, as you'll see. So when we look at these attacks, and this does vary a little bit by industry and what the different adversaries do, but we see a fairly regular pattern of attacks on our customers. There's the first host being compromised is really preceded by a period of research and preparation, where the attackers learn about the target, learn about the people, the IT admins, who has access to the data that they're interested in, and the like. And then there's really two hallmarks to what we see in that phase, which is that the adversaries are perfectly willing to exploit any weakness, as I mentioned earlier. And they also are very focused on the information itself. So it's when we look at the security in this way, we start to realize that it's not about the device. It's not mobile security. It's not cloud service security. It's not PC security. It's not network security. It's really all information security, and how do I protect the information where it is stored and how it's transmitted. So we really kind of view the world through that lens of information protection. The next phase of the attack, which unfortunately only takes about 24 to 48 hours, and it's a subject of this talk, it's around that credential theft. Ultimately, the adversaries typically target domain admin. They don't have to, but they typically do. And they usually get it within 24 to 48 hours. And they do this with credential theft. So they find those domain admins and where they're logging on, where they're using their credentials on the network, and then they use some tools to be able to steal those. Many of these tools are publicly available and downloadable in a lot of different forms, and the adversaries frequently also come with their own custom versions, and sometimes they use the public ones, so they're harder to detect.
So I've got a question for you. How do they get the tools onto the network? How do they get? So I'm assuming that they have to have access to the customer's network at this point.
Correct. And that transition is really after they compromise the first host. In order to start the credential theft attacks, they do have to have administrative access, which is either a local administrator credential or a process running as that account or as system. And so once they have that, they can start the credential theft. Prior to that, they can get onto it through phishing the user, through drive-by attacks where they post malicious code on websites. And they can also target the websites that they know users will visit in what we call a watering hole attack. So there's a lot of different ways that they can get it, but ultimately it's all about getting that first host. And then once they have that host, they start the credential theft.
Okay, thanks.
Cool. And so this phase, usually the credential theft phase usually ends when they get domain admin, at which point they then start going after the data that is really of interest to them. Sometimes they use fake or Trojan accounts, and they create these accounts and then use them, and they're not domain admins that are accessing it. They're a name that looks reasonable, and people wouldn't question that account being created on the network. And sometimes they actually directly use the administrator account. So it varies depending on the attacker. The unfortunate part about this is once they have achieved this compromise level, it usually does take about a year roughly on average to detect these attacks. Sometimes it's a matter of weeks or months, sometimes it's a matter of 2 or 3 years, but ultimately on average it takes about a year to detect these types of attacks. And that's one of the big challenges around it. Because by the time you get to that point, the backups no longer are useful for you to go back to it. And the reason why it's so challenging to detect these is because they're using legitimate accounts. They're actually using the real credentials of these accounts. And so the other challenges that we see in this space, of course, is that they're simply not detected, and then what to do when they're detected, and to make sure that you have an appropriate response that has a good investigation and a good understanding of the current attack in progress, and then a path to recover out of it. And so those are all areas that our team helps our customers with.
Hey, I've got one more question for you. So if somebody steals my credentials and they're using my credentials, or they've stolen my hash more precisely, and they're using my hash. Mm-hmm. What if I go out and what if my company has a password change policy or something along those lines, and I change my password? Does that affect my hash? Can they still use my hash?
So the password hash, which we'll discuss a little bit more as we get into the attack here, the password hash is derived directly from the password. So when your password changes, your password hash changes. It's just as unique as your password, as it were. It just happens to be in a format that the computer can use and process its fixed length and the like. So as your passwords change, then the ones that the adversary has a copy of will actually also change, and so that the adversary will have to continue to steal those in order to maintain a long-term presence. So, but they will be able to use them as long as the password is good. And frequently we find that the adversaries not only steal the credentials, but they also maintain a set of malware, and usually anywhere between 10 and 50 hosts, because they do have to maintain these hosts and they don't want to be detected. But they have an amount of compromised hosts on the environment, as well as the credentials, and so they can steal the credentials if they change again, or they could use the credentials to implant more malware if the malware gets cleaned. So we find that they're pretty flexible from that standpoint.
Okay, thanks.
Mm-hmm. So this next part is really diving into that 24 to 48 hour period, and what does that really look like? And this is kind of the focus of that credential theft piece. So the way they get in can vary. There's a bunch of different ways, but phishing tends to be a way that's very difficult to detect, very difficult to trace back. So it's a very popular method. We have seen attacks on web servers to use as the first beachhead in, but the phishing is the most popular. So the key is, in order to transition there where they can do the credential theft, is they do have to get those local admin credentials. And so once they do that, they then grab those and then they use those to compromise more hosts, steal more credentials, compromise more hosts, steal more credentials, all the while targeting, in most cases, the domain admin account. And so in this case, the adversary, on the third machine, he found the domain admin credentials, which is a very typical scenario. And then once he starts using those, he ultimately has those credentials. He ultimately has what we call shared control of the environment, because he can impersonate the domain admin anytime he wants, and the domain admin does have direct or indirect control over all the systems, all the data, all of the files, all the applications in the environment. So it's a very serious situation when an attacker gets this level of access. And it's also very difficult to find them and to remove them, which is why we generally recommend professional services for doing that, whether from Microsoft or from another provider. It is a very challenging situation. But the keys that we found to prevent this from happening, there's a couple pieces to it. The first is that you need to be able to prevent that escalation of privilege, because having administrative control over one machine or all workstations shouldn't enable you to easily have control over the whole domain. So what we've identified is a tier model, and this is published in the white papers, where we classify a Tier 0 asset as a domain controller, as a certificate authority or management tool that is in control of those or managing those. And so we've identified that domain admin, enterprise admin, and the assets that are also at that privilege level are at Tier 0. Then we have our enterprise services, which include typically cloud services at that Tier 1 level. So enterprise applications, server admins, that level of access we call Tier 1. And then at Tier 2 are your kind of device and workstation administrators. So making sure that so all of the help desk admins and the folks that have control over those PCs and devices, those guys, those single user devices, those guys we classify as Tier 2. And the idea is to make sure that if I get control of Tier 2, I don't have, through credential theft or an application configuration or a service account configuration, I don't have the ability to take over a Tier 1 or a Tier 0 asset. And so it's really about compartmentalizing and containing that. And this really follows along what we call our assumed breach, our assumption of breach, whereas you assume that any given asset might be compromised at any time, and then you build your defenses so that the higher value and higher impact assets are not able to be compromised automatically from that. And so we practice both a prevent breach, which is the classic security paradigm, as well as an assume breach, which is, well, in the event that our prevention doesn't work, how do we make sure that we protect the most important stuff? And then the second piece is, within the credential theft world, as well as to a degree applications and services, we want to make sure that there's no peer-to-peer control. And a very common example of this is most organizations that we work with have the same local administrator password on every workstation. And they also typically have the same local administrator password on every service, or on every server rather. So making sure that knocking over one machine and stealing that password hash from it and using it against the other machines, we want to make that as difficult as possible. And we also worry about the domain accounts, such as a help desk admin being lured to a PC. We've actually seen adversaries create support issues to lure an admin to a PC so that they can steal the credentials from that support person and then use those to compromise other machines. So that's another area that you do have to mitigate as well for these attacks. But once you put that in place and you have these mitigations there, knocking over any one machine does not get an adversary to the data that they want to. And they have to be much, much more precise in targeting the users that they want to, which is much more expensive for the adversaries. And they can't afford to attack nearly as many customers if you're forcing them to get very precise and socially engineer the specific people that have access to that data. So in addition to the public white papers that we have, the Pass the Hash version 1 and version 2 white papers that address this area, we do have some services solutions that we've built and deployed for our customers a number of times to help protect them against these kinds of attacks. And so the way we approach that is we always start with those elevation of privilege or escalation of privilege mitigations first, and then we look at those lateral traversal mitigations and make sure that we have unique random passwords on the workstations, or at least group policies that prevent the local accounts from accessing the other machines. And then we have application service hardening, where we make sure that those that those applications, such as a System Center Configuration Manager or Landesk or Altiris or a System Center Operations Manager, we want to make sure those guys aren't violating the tier model and providing the adversary that alternate path. Then we have a solution that we call the Enhanced Security Admin Environment, and effectively this is a reference architecture that we help deploy. We describe this at a high level, pretty decent amount of detail actually, in the Pass the Hash version 2 white paper, and we cover how we actually build this and essentially the requirements we build to. But ultimately what this is it's a dedicated administrative forest and dedicated administrative workstations with accounts in that forest that are used for domain and enterprise administration only. And the idea here is, in the event that you have a production environment where you have a question over it, is this thing still high integrity, or is it possibly compromised and we aren't aware of it? And so we set about answering that question, and that's what the Enhanced Security Admin Environment is. How do we protect domain and enterprise admins, and through them the forest, without when we have a potentially compromised forest? How do we protect that environment from the forest, and how do we essentially set up a new root of trust that's a higher integrity and extend some of that higher trust to the production environment? And we also include security alerting there and smart cards for the accounts and a number of other security controls and protections, including IPsec.
That's awesome. Is there a good way to determine, is there like a top 5 you may be hacked if list somewhere, or, you know what I mean? Is there a good way for a customer, is there something a customer can go and look at to determine that maybe they've been hacked, maybe their credentials have been stolen?
That's a very good question. There's different ways that you can detect it from a business standpoint as well as a technical standpoint. From a business standpoint, if all of a sudden your competitor is constantly ahead of you and they have access to information that is surprising that they shouldn't have access to, that's one way to do it. Unfortunately, most organizations actually get a call from the FBI or some equivalent agency in a different country, and are told that, hey, we found your data on some other network or resource or attacker control server that they just found and took down. That's usually how most organizations find out, unfortunately. But the best way to detect it, and this is actually in the Pass the Hash version 2 white paper, is you really need to know what normal looks like, because when the attackers are doing this, they're not doing the same kinds of things with the accounts that the legitimate admins would. So if you have an understanding and a definition of what normal looks like, and then then you're either looking at the logs or alerts or a SIM tool, a security information and event management tool, or any number of ways of looking at the event logs. But if you notice that your admins are logging onto places that they shouldn't, and from places they shouldn't, if you're seeing unusual connections that are definitely not normal, then that's the best way to detect it early from a technical standpoint. But it requires knowing what normal is for your organization, because it's a little different for each organization, whether you're spanning across 3 continents or whether it's a small organization that works 9 to 5 on the East Coast only.
Yeah, so you'd have to have like a benchmark, right? You'd have to have this is normal behavior benchmarks in place.
Correct,
so that
exactly.
So that you could tell what's normal and what's not normal.
Yep.
Cool. Awesome.
Cool. And so the admin forest is the most extreme way of doing it to get to that high level of defense that will stand up to even a compromised forest. So that's the strongest defense. But ultimately, what that's really built on is that sense of a known good host. Because when you're managing an environment, you're trusting every host that you log into, every host where you type your credentials, including the ones where you RDP to them. You're trusting that host with those credentials, and you're trusting the security of that host to secure those credentials. And so in the admin forest, there's a lot of stuff there to help keep those hosts clean, but it's really about those dedicated admin hosts where the accounts log on, because that's the only place they can log on. And so for the Tier 1 and Tier 2 administration, we also have a solution that we call Privileged Account Workstation, very similar to the admin workstations in the ESAE, but they're dedicated towards Tier 1 work, so managing cloud services or managing enterprise applications or server administration is another common scenario. And so that's setting up that known good host that you can't just browse the internet or check email on. It's really a dedicated admin console for doing that administrative work. And so we call those that solution PAW, and we use that to provide that known good host for managing help desks, for help desk personnel to manage workstations, for server admins to manage servers, for cloud service admins to manage their Office 365 and Azure instances. And then one other aspect to this that's actually also very important is getting to least privilege is very difficult. So when you think about a typical admin account, most of them have permanent access to all of the permissions they could ever need, and that really doesn't follow the principle of least privilege well, even though it's practically what most organizations have had to do, just simply to be able to get the job done. But one of the things that we've done, and this is similar to other industry solutions, and it's actually a solution of this type is actually going to be built into the next version of Microsoft Identity Manager. We have a solution that we call Mars that provides temporary access to privileges. And so what that allows you to do is, instead of saying, well, you're this kind of admin, I'm going to give you everything you need all the time, I'm going to give you just the permissions you need on demand, and just go through a very quick workflow on the way to it, or in the beginning of the morning, give me 8 hours of access to these privileges, or I just need it for an hour to finish a task. And so based on a FIM workflow, a Forefront Identity Manager workflow, we can provide that temporary access to these admin accounts, so they only have it for as long as they need. And we also get that benefit of having visibility into these accounts, so we know when admins are. So it gets you a little bit closer to that definition of normal, that, hey, this is what normal looks like, and if I see the privileges being used outside of that pattern, then I actually have a normal, a baseline, a benchmark to compare it to.
And I'm just assuming that we track that and log all of that, et cetera.
Exactly, yep.
Yeah, okay.
And then the last couple pieces that we do is there's a couple of new technologies that came out with Windows 8.1 and have several of them have been backported to Windows 7 and Windows 2008 R2 and up, so everything after that. And one of them is this is my favorite feature that they've added recently. It's called RDP in restricted admin mode. And what this allows is, in a normal RDP session, if I go and I RDP to a terminal server, I am giving my credentials to that terminal server, or to that server, to that domain controller, whatever it is that I'm managing at the time. Or even if I'm a help desk guy, I'm supporting a workstation, I'm giving my credentials to there. And that's very challenging because it keeps those credentials exposed in a lot of places. And the great thing about RDP with restricted admin mode is I can get that RDP experience, I can get the full screen, I can get that everything it looks, feels, and it is a normal RDP session, except that I don't actually put my credentials on the remote end. I just do a network authentication of the box instead of giving the credentials to it. And so this is a really great way to prevent the spread of all those privileged credentials out there. And so we recommend it for help desk admins, for server admins, and the like. And so that's something that we do for all of our PAW solution deliveries as well. And then there's another concept that was introduced called protected users. And protected users, you effectively need to have a 2012 R2 domain to take advantage of at a domain functional level 2012 R2. What these are Kerberos-only users. So you drop a user into this group, and the domain will only authenticate them over Kerberos, and it will not use the weaker cryptography. It will only take the stronger authentication for Kerberos. So it's a very, very powerful feature there. And then once you get to Kerberos-only accounts for these admins, after you do the app compat testing to make sure your apps and printers and the like don't require NTLM, once you get to that point, you can implement something called authentication policies and silos that are essentially Kerberos policies, where you can determine where these users can or cannot log into. And that really strengthens those those tier boundaries to where the domain controller is enforcing and saying, I will not give you a ticket, I will not validate your NTLM request. Well, you can't do NTLM with protected users, but I will not give you a Kerberos ticket unless you are pre-authorized to log on to that host. So for these very sensitive admin accounts, it's a very powerful way of restricting where they can be exposed and where the credentials can be exposed.
Mark, what about two-factor authentication? Would that mitigate a lot of this?
That's actually a very good question. The answer is, if you have a trusted host, then two-factor authentication, you get essentially what you get advertised on, in the brochure. But if you have a compromised host, we found that the two-factor does not help. And the reason for that is, if I log on with a smart card, which is the most common form of two-factor, then I still have to work over the NTLM authentication protocol, so I still get an NT hash, happens to be handed to me by the DC over that smart card logon procedure. Or if I have a Kerberos ticket, which is another form of credential theft, my smart card logon has to be Kerberos compatible, so I'm still going to have a TGT in the session key to decrypt it, and the adversaries are able to steal and reuse those as well. So the reality is, unfortunately, we love multi-factor, and if you have that trusted host, we embrace multi-factor, and we have it in our admin forest reference architecture. But it will not just protect you directly against credential theft. So great technology, it just relies on the trust of the host.
Is there anything that could be done by us, by Microsoft, to mitigate the pass the hash vulnerability?
Very good question. There's a couple things that are being done by Microsoft. The biggest challenge the question that we get very frequently is, why can't Microsoft just issue a patch? Monthly bulletin, Patch Tuesday, why can't we just magically fix this? And the reality is that we can't. And the reason for that is that if you look at the way a credential theft attack works, it's effectively exploiting an operational decision. So where I'm an admin and I use my credentials in different places, my credentials all happen to be a single factor. They're a single piece of data. The password hash, the TGT, and all of those things are perfectly portable. And so these things can be stolen and reused in different places. And when you look at that, it's the nature of the protocol and the nature of the credential types that make it susceptible to this theft. And so one of the things in the Windows 10 timeframe that's coming is hardware-backed credentials. So they are working very diligently on what is, it's an internal code name at this point in time, but it's called NGC, or Next Generation Credentials. It will have a much better marketing name soon. And there's a number of TechEd Barcelona sessions I can point your viewers at that address kind of a little bit of how this works. But the short answer is it's TPM backed. And so the credential itself is stored in the TPM, the private key is stored in the TPM, and it cannot be stolen from the machine because it's hardware-backed as opposed to a software piece of data, essentially. So from that standpoint, we are addressing that and working through that. And the biggest challenge when you have something that's as portable as the current generation of credentials are, is that they can be stolen and reused. And so you're really looking at your kind of your people, your process, your technology to make sure that when the admins are doing their work and they're handling these extremely valuable, extremely powerful things, you want to make sure that they're as secure as possible in their practices. And so, many of those solutions that we discussed earlier, we always recommend doing a little bit of IT process consulting along with those solutions, so that the admins have when say my admin workstation is broken and I'm supposed to use it, and my boss is telling me I have to do this task. Well, we want to make sure there's a process in place that says, okay, this is how we do it securely in an alternate way. This is how we make sure that you have a backup plan so that you can still do everything securely even when the operational stuff breaks. So it's really two different things. One, we are improving the technology. You saw some of the Windows 8.1 features. The Windows 10 stuff is getting even better. And at the same time, you got to focus on the administrative stuff and the people in the process part of the triangle. Does that help?
Absolutely.
So this is a quick demonstration of how the credential theft attacks work. This is actually going to be a pass the hash demonstration, but I'll tie into a few other attacks as we go through it. The demo environment is actually quite simple. There's a domain called domain, a DC in it called DC, a domain controller called DC, and then there's a client in there. And this is effectively what I call the unsuspecting admin scenario, because the domain admin does not know that the attack operator is in control of the client he's about to use. And so that's the story that we'll be showing here and how it unfolds. So domain controller here, we're just looking at the root of the C drive on the domain controller, pretty standard Windows basic implementation. And then we'll take a look here and log into the client. And so we're going to log into the client here with a local account. So this is an account that does not have privileges on the domain. It is just a local administrator on this particular client. And we'll show first off that he doesn't have access to the domain, and then we'll show how he takes those local admin credentials and elevates them and elevates his privileges by stealing the credentials of another account, the domain admin account. So as this local admin account, we're going to go ahead and take a look and see what we've got for access and privileges. And we do have to do this with administrator privileges, so we'll have to hit yes to the user account control prompt here.
Okay. And so for people that are just listening to this, he's got a couple of VMs set up. He's firing up an admin command prompt on the client VM, and he's doing a net use.
Yep. And I'm going to first net use to the domain controller just to show that I don't have credentials. It's prompting me, so I don't have anything. So now as the attacker, and so I'm in the attacker mode, the attacker persona. So I'm going to go to my pass the hash folder, and I'm going to go ahead and run a tool called Windows Credential Editor. And to be clear, this sounds like, but it is not a Microsoft tool. This is actually a security researcher tool, aka a hacker tool, that's published out on the web, freely available. This tool is detected by antivirus, so I've had to turn that off for this particular folder for the demonstration purposes. But the techniques it uses are not detectable. The behaviors are not detectable by antivirus per se, so an attacker can create a custom version of this tool fairly easily that will evade antivirus that will accomplish the same thing. But this is a publicly available utility. So
are those the hashes that we're looking at?
That's exactly correct. Those are the local admin hash, which is what I'm logged in as. You'll notice that there is no landman hash in memory. And then the pass the hash, the client machine, the machine $ account there is also available for theft. And as an attacker, this doesn't get me a whole lot. And these are the accounts that are logged in. And to be clear, these are the ones that are running a process at this point in time. So whenever I log on to a Windows machine, I want to automatically log on to a SharePoint server, to an Exchange server, to a file share, and I don't want to be prompted for credentials. And the way that actually happens is the LSAS process, the Local Security Authority process, stores a copy of my credential on my behalf, and in a very secure, encrypted way. Now, it is secure and encrypted and hidden. Unfortunately, the attackers have had a number of years and have figured out where it's hidden and where it's encrypted. And because the system itself has to have access to the credentials, so too will anyone that gets system-level privileges. And this is why local administrator privileges are so critical, because they allow you to impersonate the operating system and get access to whatever's stored and hidden and encrypted by it. So that's the biggest challenge here, is that with the software-backed credentials, they can be stolen. So the other thing that an attacker can do, because right now what we're looking at is a set of credentials that don't give me any more privileges. But an attacker can look in a couple other places. They can look in the local SAM database, and so running a tool called pwdump, another freely available tool, you can dump the contents of the local SAM database and get those NT hashes. And so they can steal that local administrator password hash and then traverse to other machines that have the same local admin password. But what I'm going to do now is I want to elevate, so I'm going to do a WCE-E, and what that does is it's the same thing as the first command, but it will wait for a logon event, hence the E, and it will go ahead and re-scrape memory every time there's a logon event to see if there's any new credentials, and then it'll post them there. So
by the way, I want to point out that you're getting flagged for potential potential harmful software detected.
Correct. Yes, the anti-malware agent does know about this particular tool, so good catch there. So we're going to go ahead and switch users. So we're going to start a whole new logon session as the domain admin account. And this is where we're switching to the domain admin. And the domain admin is not aware that this computer is compromised. So he is just logging into his daily workstation. And the domain admin credentials are now compromised. And all of the things that it directly and indirectly controls are compromised. So at this point in time, the entire environment is potentially compromised. It's a matter of the adversary doing something with that control. So if you want to see what this looks like, the one thing to keep in mind, and this ties into the earlier question, that there is no obvious sign that a credential theft attack has occurred. And this is why it is such a difficult attack to deal with, because there's no indication that I've just lost control of my credentials. So I'm going to go ahead and switch user back. And I'll take a look at from the adversary's point of view and see what the adversary is able to see as that local admin.
Yeah, so at this point, all that's happened is the admin is logged in.
Correct. And when they logged in, you can see now we have a domain admin credential. And you may think it would be difficult to use something like this, but the reality is I'm not a very good hacker, but I can copy-paste, so I'm going to copy that. And when I do a WCE-S, what it'll do is in the LSAS process, and there's other ways of using this credential as well, but in this case, I'm going to go ahead and inject that credential in place of my own. So instead of the local admin credential being associated with this session, it'll now be this domain admin credential. And so it's successfully changed out. And when I do a net use to the DC, and what the heck, let's map a drive, and let's go for broke. Let's map the $. I now have drive Y. So if I can go here and look in the PTHDC on the left, you notice as I make the hacker tools directory, it's happening in real time. And I, as an adversary at this point in time, would typically upload a tool that would dump the hashes of the entire Active Directory database, and that way I would be able to impersonate any user for as long as those passwords are good.
Wow, that's pretty scary. So, so all you did was cut and paste the hash into WCE, essentially.
Correct. From WCE to and back into it.
Yeah.
And the key thing here is what you saw was three things coming together. The attacker had control of a machine.
Right.
And the credentials were there and present on the machine. So the admin could log on to the machine, the adversary could compromise it, and then the adversary was there to actually compromise it.
So initially you didn't have the admin's credentials until he logged in another user session.
Correct.
And that's just because those credentials weren't active at that time.
Correct. There was no credentials there to log in. There was nothing cached. Right. There was nothing in use. Yep.
Okay. So are we working against the cache? Is that what we're working against?
Yes, it's a cache of credentials in memory. And just to be clear, this is not the same as the cached logons you would see in group policy, which very, very different technology. Those are actually cached logon password verifiers. They are not composed of the NT hash that you just saw. They're composed of it's essentially a hash of a hash. It's 10,000 iterations of a hash algorithm of the hash. So it's a very mathematically distant value from this, and it's very, very difficult to even create one, and it's extremely difficult to crack it back to the original hash. So from that perspective, you don't have to worry about the cache logon count for this particular attack. It has no bearing on it, but where the admins log in, period, and whether or not those machines are easily compromised or subject to internet risk like phishing emails, those are the two main factors you have to worry about.
Wow, that's good stuff. And I think it really drives home the point that, even if you think you're really secure, unless you're set up optimally, you may not be as secure as you think you are.
Yep. And that's why we have so much, honestly, services business helping our customers with these attacks. It's also why we've published the Pass the Hash version 1 and version 2 white papers. The version 1 is all about answering the question, how can I stop this attack as soon as possible on my network? And that's really what the version 1 set out to answer. There's step-by-step, click-by-click instructions on how to set up the admin workstations at an immediate basic level. And then Pass the Hash version 2 was really the follow-up on that to address the questions of how do I strategically deal with this, how do I integrate this to all my defenses, how do I have a life cycle of how I deal with credential theft, and as well as having information on our advanced solutions around the admin forest and how we build our admin workstation defenses up. So, it's really a two-part story there to help customers with this. And of course, if you want to engage Microsoft to help, we're very happy to do so.
I know that we have a services offering called a security review, and I think it's just a basic review of where you stand from a security standpoint. Are you familiar with that one?
Yeah, there's a couple different assessments and reviews that we have. The Microsoft Security Risk Assessment addresses the strategic overview of, hey, what are the areas that we should be worried about, and credential theft is always near the top of the list. And then we also have detailed assessments of your Active Directory security, which help discover not only the problem that you see here, but a number of other ways that an attacker could get your AD.
Wow. So which offering would you recommend if somebody wants to do one of those offerings, but they've never done one before? Which one's a great one to start with?
A great one to start with is the offline assessment for Active Directory security, or we call it OADS. And that one really gives you a really good depth of what's going on in your Active Directory. If you're looking for a more general security starting point, that's the Microsoft Security Risk Assessment, or MSRA. So those are great ways to start. But we don't want you to just stop at an assessment, though. We want to make sure that you actually solve the problems either with the white paper or with some of the PAW or ESAE offerings.
Absolutely. So if you're listening to this or watching it, and you are a Premier customer, contact your technical account manager if you're interested in any of those security-related services, and they will get you set up and hooked up right away. Mark, anything else cool to show us today?
That's all we got for today.
Awesome. Well, guys, there you have it. That was really enlightening and a little bit scary, actually. But if you have any questions, feel free to ping us at topp@microsoft.com, or just leave a comment on the Channel 9 page, and we'll get it answered for you. In the meantime, if you're interested in any of these services, again, contact your technical account manager. And without further ado, that's your taste of Premier.